Today, we'll go through a few common refactorings that can be easily done with the help of your IDE. So first, what is code refactoring? Well, code refactoring involves modifying existing code without changing its observable behavior. And that is the key, without changing its observable behavior. Oftentimes, people confuse restructuring with refactoring. Refactoring is meant to be smaller in scale, and because it doesn't change observable behavior, it can be done incrementally. Refactoring improves the code base's readability and maintainability. We also made a video on why readable code is important, and there's a link to it in the description. But the issue with refactoring is that many engineers are actually afraid of refactoring. Refactoring is essential to software development and should be done regularly as part of your day-to-day work. As you're making changes, new features, or bug fixes, you see something that you can improve, go ahead and do it. Do the refactoring and leave the code better than it was when you found it. But some engineers are afraid of refactoring, they don't know how to do it, or they don't consider it a part of their job responsibilities, meaning they're expecting their manager or someone else to tell them to do it. So let's go through some issues why engineers are afraid of refactoring. Some fear that refactoring will introduce bugs or break existing functionality. And the root cause of that fear is the lack of automated tests. And without automated tests, ensuring that refactored code behaves as expected is difficult, although the refactorings I will show you can be automatically done with your IDE, which should alleviate that fear somewhat. Of course, the best thing to do is make sure you do have automated tests in your code base, right? A code base without automated tests is like a ticking time bomb and cannot be maintained by any sane engineer. The second reason engineers fear refactoring is they say it takes too much time. We've got deadlines, bugs, new features, pressure from management. But the reality is refactoring, as I will show you, can be done incrementally in small steps. For example, you can spend minutes or maybe an hour refactoring and then go ahead and merge your code to your main branch or submit your PR. And then if you want, from that point, do a few more small refactoring steps, right? Your organization should never need to allocate weeks of development just to clean up the code or do a large refactoring, right? You should be maintaining your code base in a readable state proactively. Another reason why engineers fear refactoring is they don't want to make too many changes to the code because it'll make it difficult for reviewers to review the changes. And the issue here is that many current review systems are kind of dumb. They don't understand the code changes semantics, the meaning of the code changes. They don't understand when one method is moved from one file to another. They only understand line changes and are frequently confused by relocated code. So in this case, the coder should explain their changes to the reviewer, either in text or perhaps make a video. Alternatively, the organization could adopt a better code review tool. I also had a few gripes about the Code Hub review process, and I'll link that video in the description as well. Okay, so let's jump into some common refactorings. All right, the first one is extract method. Let me talk about it first before showing the code. Okay, extract method. It takes a piece of code within a larger method and moves it to a new method. So there's several reasons to do this, and all of which have to do with improving readability and maintainability of the code. First, the most obvious one is this code. The method code is too long, and you just want to make it more manageable by breaking up into smaller pieces. Another good reason is this code is duplicated that you want to refactor out. It can be duplicated multiple times in the same method or across multiple methods, and you just want to have a single method for that. But I think the most important reason to do this type of refactoring is to separate the code implementation from the code intention. Oftentimes, the implementation is complex and takes the reader a while to understand what it does. So we want to move the implementation into its own method and then use the name of that method to signal the intention of that code. All right, now let's jump in. Okay, so we have a small program here that does some testing on packages, and we're going to be looking at this part of the code. So as I enter this expand packages method, I see a bunch of stuff happening here, not too much, and I can go here and say, okay, contains function, so it's calling this function. It takes this slice of strings, and then on each one, it's looking for 3 dots. Okay, so I can kind of figure out, takes me a few seconds to figure out what's going on here, but it is kind of cognitive load. And this, just by looking at this code, it doesn't actually tell me what the intention is, why you're doing this, right? So one way people do is add comments. Check if the packages need expansion, right? People add comments like this. But a better way is to actually extract this method and communicate the intention via the method name. So let's see if we can use automated tools here to help with this. So we highlight the code that we want to extract, and then we can right click and go to refactor extract method. I think there's also a refactoring menu here. This is Goland and the Go programming language. So there's also a refactoring menu, which can be which has a shortcut that will also. I think this is nice because you don't have to leave your hands off the keyboard. So let's go ahead and try this extract method. And this is Go language, so it can be part of this struct with the receiver as a struct, always a separate function. My preference is to keep the code with the struct because it kind of reduces, it kind of increases encapsulation, so we know that this code is related to the struct. So I'll go ahead and do that. And then it tells us the function name. And we call it need expansion. And sometimes we need some cleanup to do, right? So yeah, this is right. It takes packages and it returns packages. But actually, we don't need to return packages because it returns the same thing. We just wanted to return a Boolean. Does it, to tell us, does it need expansion or not? So we just get rid of packages here. The other thing is this not. It needs expansion if it contains the 3 dots. So if I believe we can simplify this further. We can simply just return this, right? Return. Yep. Okay. So there we go. We extracted this method. We go back to where it is. We don't need this I. So sometimes we need to kind of rewrite this. And let's go ahead and rewrite this. If so ultimately, this is the simplified way to do this. So, sometimes if you do have to strip out a few return values or inputs to your method that you don't need, but ultimately this is how you would do how you would do this method in this situation. All right. Let's move on to the next refactoring. Inline variable. Inline variable. So every variable should have a purpose and a good explanatory name that describes its intent. And oftentimes you're looking through a function and there's a bunch of variables, and keeping all these variables in the head kind of increases your cognitive load and makes it difficult to understand the code. So one way to improve readability is to inline the variable, basically replacing the variable with the right-hand side of the assignment. So let me show you a couple examples. Let's go up here. Here in this function, we have this context that comes from here, build.default. And I see that it's only used down here in this method. So what is this build default? The build default, it tells me it's the default context. In this case, this name is actually pretty poor, unfortunate, because really what I would have liked to see this name be called is default context, not just default. But nevertheless, I think it may be clear enough, or maybe it's not that significant to call out this variable. And let's go ahead and inline it. So I highlight the variable name, I go to my refactor menu, and I say inline, and bam, just like that, simple. And now, we got rid of that extra cognitive load when understanding this method, so good for us. Let's show another example here. Here, oftentimes we see things like this. We take a variable from the struct, maybe we keep the same name, maybe we give it a different name, and then we use it a couple places. But really, this name doesn't actually add anything to this code. So let's go ahead and inline this. Refactor, inline. There we go. Bam, we got rid of it. I feel like our code's easier to understand now. Okay, let's go to our third refactoring, is extracting variable. So this is when you take a complex expression and move it into a new variable. So mechanically, it is the opposite of what we just did. We did inline variable, where we get rid of a variable, but with extract variable, we're introducing a new variable. So why would you introduce a new variable? Well, sometimes your expression is complex and could be broken and should be broken down into smaller manageable pieces. Also, it may be that the meaning of your expression is unclear, and by introducing a variable, you're introducing a descriptive name for that variable that will describe the intention of your code. And you might have noticed that extract variable and extract method can sometimes be interchanged. And I would say, in general, I favor using extract method to make the code more readable, because it kind of hides the implementation details, hides all that extra code inside the function. But if the parent function is not too complex, it may be better to extract a variable. So let's go ahead and basically do our first example, but using extract variable. So let's same example as we had before. So we highlight the code that we want to extract a variable from, which kind of matches what we need down here, right? We highlight this code, we right click, we say introduce variable, and then we call it need expansion. And there we go, that's how that's done. All right, last one, inline method, also known as inline function. So the inline function refactoring takes a method and moves its code into the caller. So this is mechanically the opposite of the first refactoring we showed, which was the extract method. So we have extract method, and then now we're going to show inline method. So there's several reasons to do this. So like sometimes, well, let me start over. Several reasons to do this. First, sometimes the method that you've extracted, maybe through other refactorings, it's now too simple and its body is as clear as its name. So you just want to get rid of that extra code and move that functionality back into the main body. Another situation that may happen is there may be levels of indirection, a delegation where you call a method that calls another method that calls another method. And sometimes you just want to simplify that code and remove these extra levels. And the third reason, which I find myself using occasionally, is sometimes you have to kind of go backward to go forward. So you've got a bunch of code in a function. It's still confusing, but there's parts of it have been refactored already in its own functions, but those refactorings don't quite make sense. So you want to kind of get back to unrefactored code, like all the code in that function, before you can move forward and do a better refactoring. All right, so let's go ahead and kind of try to see what we just did here. Let's reason I uncommented this code here is because we want to see how our IDE can help us to inline this method. So we highlight this method, and we right-click, refactor, inline function method. So let's do that. And it gives us some option, whether I want to keep declaration, whether I want to remove declaration. So typically I would want to remove. So let's go ahead and refactor this. And there we go, beautiful. So easy, much easier than what we have to do when we extracted the method. All right, so just to review, the things we covered here today are kind of the two sides of the same code. We covered extracting method, a very common refactoring, and then inlining method, which was the opposite of that. And then similarly, we covered extracting a variable, right? Making a more descriptive variable name. And then the opposite of that, inlining a variable. That's it for today, and I hope you enjoy making your code more readable and maintainable.